Mr. Rolf from California, USA. Uh, Mr. Rolf is one of the original authors of the passwordless FIDO specification, and they contributed to the W3C web authentication standard. He chairs and vice chairs multiple FIDO Alliance technical working groups, including FIDO2, Metadata Service, and UAF. Additionally, he has advised government bodies and frequently speaks at industry events on topics such as FIDO, identity, IT security, and blockchain. The title of the talk is Introduction to FIDO Authentication, the Evaluation of FIDO and the Future of Digital Identity.
Morning, everyone. I'm honored to speak at this conference. As you heard, my name is Rolf Lindemann, VP of Products at Knock Knock Labs, which is one of the co-founders of the FIDO Alliance. And maybe some history, 12 years ago, that was even before the FIDO Alliance was founded, I was given the opportunity to join Knock Knock to work on a bold idea that was intended to change the way authentication works. And that idea then became the first FIDO specification. It evolved over the years, and through my work at Knock Knock, I had the privilege to help many companies deploying FIDO authentication on a global scale. And today, I really would like to share some insights about the evolution of FIDO, some recent improvements we have done, and even an outlook into the future, what things we will likely do and focus on very soon. So let's start with an overview, one of the drivers we have seen in the past. And by the way, this is a slide I've shown in 2014, right, where I was impressed that criminals have stolen 1.2 billion passwords, a very large number. Now, in a very recent presentation, I looked up that number again and found that by this time, meaning roughly 10 years later, it's nearly 10 billion passwords, meaning the problem of credentials being stolen from server did not go away. And there are other attacks like that. We have seen many of those, including the ability to attack two-factor systems, stealing digital fingerprints, also on the biometric side. And the question is, what do we learn from that? Is there something which is always a new surprise, or is there some structure in that? And really, if you look into those attacks, you see roughly there are two types of attacks. The first one that's inside the green frame here, those are the scalable attacks. Those are the attacks that really can address and target many different victims at the same time and with roughly the same cost, where the attacks on the right-hand side are more physical attacks. They are not scalable to that degree because it costs real money and real effort to run those attacks. In the end, we learn things are never 100% secure, so we need to focus on what we call robust security, focus on the scalable attacks first, and that's what we did with FIDO. Quick recap, whenever people authenticate to a remote system, like you see in this diagram, we realize that people have local reach only, meaning if we talk to a server, right, the server is far away, we need some kind of helper device. In FIDO, we call that helper device authenticator, which includes all the security relevant aspects of the authentication. For example, it includes key pairs, private keys dedicated to one app. So not only one key pair, but essentially one key pair per relying party or per user account that you have. That also means that the server on the right-hand side only needed to store a public key, and remembering the millions and billions of passwords that have been stolen, with only public keys on the server, there's nothing to be stolen, no credentials, really. So we can already protect against this type of attack there. The second part here is the user verification, right? You want some user involvement to verify whether the right user is approving the transaction or trying to trigger the authentication, or at least whether there is some human being, some user that can give you a presence check, as opposed to just malware sitting on that device. So that is what we conceptualize talking about and call user verification versus user presence. So whenever the authenticator is about to exercise a key, that user verification needs to be done. The user verification itself is also part of that authenticator. It's a task of that authenticator. Now, what we do for the remote communication, right? This is a local interaction with the user verification, which is biometrics, which only work locally. Now, remotely, there's a cryptographic challenge response protocol we run where we use the keys, we get a fresh challenge, a random challenge from the server, and provides a signed response, which was generated by the authenticator back to that server. We also allow the server to look up the characteristics of that authenticator. So authenticators might have a model ID, the AAGOID, which talks about that authenticator model, what it is, right? Whether it's from one vendor or an authenticator from a different vendor with different characteristics. And the FIDO server can look up the authenticator characteristics from the FIDO metadata server to learn more about that security level the authenticator might have, potential certifications the authenticator might have, and other detailed characteristics. Now, what that means in total, that we get out of that trade-off scenario where you have systems that were either usable or convenient for users or secure on the other hand. And if you depict that in a two-dimensional chart, you see that with passwords, right, you have really poor usability and very weak security. With OTPs, you get a little better security, but the usability really suffers from that. Where the observation is with the concept of FIDO, you improve the security significantly, and at the same time, you also improve the usability for that. So what we really get to that with FIDO, we have an open standard for simpler and stronger authentication at the same time using public key cryptography. And I will talk about more regarding the cryptography versus infrastructure, PKI versus public key cryptography a little later. So it's really, there's a single gesture, even for multi-factor authentication, not two different steps. It's possession-based because you need to have the authenticator itself. It's phishing-resistant authentication because those credentials are related to an account and the relying party at the same time. Now, the life cycle of the authenticator typically is you have to register authenticator first, you have to bootstrap the new device if you get a new device, and then re-authenticate, right, subsequently on the same device. And if you look at the traditional way we do that in FIDO, right, for registering the first authenticator, we typically require people to sign in using a non-FIDO method, right, the legacy authentication to understand who that user is that then will register the FIDO credential. For bootstrapping a new device, right, that was using non-FIDO methods to then register the authenticator on that new device, right, or the new authenticator. And if there would be an authenticator available, right, use non-FIDO methods or the security key to be plugged into that device. For re-authentication, this is a simple use case. That is what we addressed, right? Single gesture, multi-factor authentication. So the re-authentication from that perspective is really the use case we addressed with FIDO early on. And we will get and see how FIDO was developed and evolved over time. So it really is benefits for the user. No need to think about devices when using passwords. So that's the difference to FIDO, but having a strong device binding and that provides strong multi-factor authentication when using FIDO. From a historic perspective, you see that the first FIDO specifications were really kind of twofold. We had a passwordless FIDO specification providing phishing-resistant MFA, but only in native apps and only using platform authenticators. Where on the other side, we had security keys providing phishing-resistant MFA in web applications using security keys as a second factor, which typically requires a password as a first factor. So it's really, you see, FIDO was a twofold world, right? Passwordless on one hand side and security keys on the other hand. In the second generation, we then made sure that passwordless would also work with security keys. That's a change number one. And number two, that passwordless would also work with security keys in web browsers. So we brought the security keys to the native apps on one hand side, and we brought the passwordless authentication and the platform authenticators to that to the browser world as well, which were very significant improvements there to get FIDO across all the different application types, like native apps and the browser, and allow you to use passwordless in web apps and in native apps as well. Right? So really bring the two worlds together, make it a single world. In the next revision of the specification, or the big milestone was really to be able to use a phone as a security key, which is now called FIDO cross-device authentication. And second, allow the use of biometrics without a PIN in a security key, right? So further step to make security keys and platform authenticators very similar on one dimension, and second, reduce the difference between security keys on one hand side, which were portable, and platform authenticators, which couldn't roam to and be used with other devices, right, through the FIDO cross-device authentication. In 2022, there was another big step forward, and that was on multiple dimensions. The first is we introduced the term passkey and an icon along with that. So the first time we really had a consumer-facing branding, if you will, from FIDO. And if you do a Google lookup and see how many hits you get, right, how many different search results you find, if you look up that term, you see that there's really a big spike, right? When people started talking about a single term as opposed to using your device, right, to authenticate whether it's you. Now you could say use a passkey to authenticate, and people would understand that, platforms would use that icon as well. At the same time, we added one more thing, and that was the support for synced passkeys, meaning allowing an ability for a FIDO credential to travel from one device to the other, and especially realizing that users typically have multiple devices, right? So I have a smartphone, I have a laptop, and I have a tablet, and it would be very inconvenient to register multiple credentials for each of those devices individually. It's much more convenient for me to create a credential on my smartphone first, and then let the credential travel to my tablet and my laptop as well. Right? So support for sync passkeys now is available in the platform authenticator, and technically it would also be available for the security keys, even though I haven't seen any real implementation of that. And technically, a passkey is just a discoverable FIDO credential, so something you can use without a step before that. So it's really the passwordless authentication. Looking at that, how FIDO works picture again, so what did really change? And this is an interesting observation here. Nothing really changed on that level. So you still see everything that you have seen before. The only thing that really changed is an implementation detail of the authenticator. So authenticator vendor could just implement a method to migrate or synchronize the keys, right? Potentially through a cloud service, but not necessarily through a cloud service, from one authenticator instance to another one. For example, from my smartphone to my tablet. This really changed a lot of the characteristics and did not require a big specification change, right? So we did some things to make that easier and to reflect that fact in the specifications. But in reality, this was just an implementation detail of the authenticator, which really made a big difference to that. Now, looking at the life cycle again, having the traditional FIDO really adding a lot of value for the re-authentication use case. Now we see that the passkey, the synced passkey approach also extends that benefit to bootstrapping new devices. You still need to use non-FIDO authentication as a way to authenticate before the first passkey is being created. That's a clear thing, right? That would be another topic to address that. Wallets will likely be used for that purpose. But bootstrapping new devices and re-authentication now are both addressed by FIDO, which really helps us to address the 90% use case, meaning the password replacement as opposed to only MFA replacement. Complex device management and user verification are practically kind of outsourced to the passkey provider, right? So the passkey provider takes care of that you as a relying party, which is interested only in a password level security, just a little higher, like phishing resistance already, right? So you do not have to take care of how users would migrate from one device to the other. Now, interesting aspect here, comparing FIDO with PKI, right? Sometimes people think, oh, you are using cryptography, public keys, right? So why isn't that PKI? So here's some differences. Let's walk through that. The first thing is, in the FIDO world, we really have the concept of an authenticator, where the authenticator itself has multiple components. And let's start with the view of the FIDO authenticator and the components of the FIDO authenticator, really, right? Which is a similarity, right? Both of those authenticators, right, contain keys, and they can be protected in software and trusted execution environments and TPMs or even in secure elements. But now we have some differences as well, right? Looking into the FIDO world, right, and at the differences, we see that FIDO is based on a direct trust model, right? There's the user that authenticates to a relying party, and there's no third party in between. Where in the PKI world, you have certificates which need a registration authority and a CA infrastructure, like the infrastructure, the I in the PKI world, right? So that is the difference between FIDO, direct trust, and PKI, the third party, the certification authority, if you will. There's a second one. If with the FIDO authenticator concept, it supports bring your own device or own authenticator model, where the attestation helps the relying party to understand the characteristics of that authenticator. Where in the PKI world, that doesn't really work, right? So it's either the smart card or the credentials issued by the CA and the hardware is provided by them, or you have bring your own authenticator, meaning I can buy my smart card and just create a certificate on it. But in that case, the CA doesn't learn the characteristics of that smart card and it might not even be one, right? So there's another difference here. Another difference, in FIDO, we have a key which is tied to a relying party. So if I have account at bank 1 and another account at bank 2, I would already have two different keys, which are implicitly and automatically managed by the FIDO authenticator. In the PKI world, it was really designed to have three different types of keys, but they were shared across all relying parties. One key for signing, one for non-repudiation, and another one potentially for encryption. Yet another difference here. In FIDO world, only privileged components can assert the relying party to the authenticator, meaning it's either the browser or the platform, meaning the operating system itself, talking to the authenticator and telling the authenticator, oh, you're just browsing to bank1.com, or you are opening bank2 native app, right? In the PKI world, any native app would have full access and browsers would barely support that. And you would have to install third-party drivers or middleware, right, to get that. From a cryptographic perspective, we know that all the keys in the PKI world would allow you to sign arbitrary hash values, right? So technically it's an uncontrolled to be signed object, where in FIDO, we take in potential random challenges, right? Hash values from the outside world, but the FIDO authenticator would include that hash value just as a part of an of a to be signed object, a well-formed FIDO assertion, right? So FIDO always controls the to be signed object. It's not an arbitrary thing from the outside world, which means we don't need different keys for signing and non-repudiation. It's just one key is enough for that. Then user verification, the last one, dynamically used and asserted by the authenticator itself, where user verification in the PKI world is captured outside, like a PIN for a smart card, for example. It's a static method, and the smart card doesn't even know whether that was freshly captured from the user or not, right? Then there's dynamically used transaction confirmation display, where we have that in some FIDO specifications. In others, we are still in pull request open to work on that. But in the PKI world, there's no ability to really enforce the non-repudiation part, even though the key talks about that. But it's reliant on an outside component where no one knows what that component is. So just saying, there are several differences for good reasons between PKI and the FIDO world. The most relevant one, in my opinion, or apparent one, is the I in the infrastructure, right? That in PKI, that doesn't exist in FIDO. It's just public key cryptography based. Now, what do we think will come next? So we have an interoperable ecosystem for authentication. We have addressed the device migration, at least for unregulated markets. We have already implemented the user choice for credential providers, pluggable passkey providers as a key term here. We have expanded that to payments, secure payment confirmation. We are now working on the verifiable consent, right? That is one of the pull requests I just mentioned. And the next thing we expect to happen is to address device migration for regulated markets where device-bound keys and attestation for that and things like that, device binding comes in and need to be addressed on a different level. And for the unregulated markets, we expect to see a convergence between wallets on one hand side and passkey providers on the other hand. And I recently did a talk at the European Identity and Cloud Conference on that topic, to then reach an interoperable ecosystem for reusable identity, where it really gets easy to sign up to new accounts, right? And then do the device migration and the re-authentication in an easy way with robust security. And this is what I would call the e-promised land, right? This is the world where we want to get to, with robust security, very convenient for the users. So that is what I wanted to share. I think we have now some time left for questions.
Mike? Please, Professor.
Yeah, thank you. I have a question. One of the challenges in the phishing is it's a lookalike this one. Like if I want to interact with a bank, it looks alike because I don't check whether this is the real bank with which I am doing it, kind of a thing. But with FIDO, I am not understanding how that challenge is being taken care of.
Okay, very good question. Thank you for that. So let's walk that through. In a FIDO world, let's have a user that has a web browser, now opens bank1.com, right? And he thinks he opens bank1. Maybe he clicked on secure-bank1, which is a man in the middle side, right? I think that's the scenario you're describing, which looks exactly like the bank1.com website. Today, I would enter my password and even the OTP, and the man in the middle would say, thank you, and now owns the authenticated session. In the FIDO world, it's different. In the FIDO world, the browser would talk to the operating system and say, okay, I want to do FIDO. And by the way, the relying party ID, right, the URL I'm talking to is secure-bank1.com. And now, different from human beings see secure.-bank1 and say, okay, that's even more secure than bank1.com. And it's bank1 is included, right? And they might think it is bank1, right? So whatever you do, you are really convinced this is bank1.com. And the FIDO stack would just say, no, it's secure-bank1.com. Do we have a credential for secure-bank1.com? Very strictly. And the FIDO authenticator would say, no, I don't have a credential for securebank.com. And especially the bank1.com credential will not be used for that. So from that perspective, the ability that there's a direct browser integration, right? The check of the relying party ID happens in the platform itself and does not rely on the user to check whether the URL, right, is really the bank and the certificate matches and all that stuff. This has been automated inside the client-side implementation of the FIDO stack in the platforms like Windows, iOS, and Android, and it's also being implemented in all the web browsers today. So really, that the notion of that private key being tied to the relying party ID or the URL you are talking to, that makes a difference, and that makes it phishing resistant in this case. By the way, NIST SP 863 calls that verifier name binding. And that is exactly that thing that FIDO provides. On a second level, right, there are even more things like token binding, other methods you could use, but that's a more detailed discussion. But large scale, it's really that verifier name binding we are doing in FIDO that helps against phishing attacks.
Is there a overhead or a performance degradation?
No, not for the verifier name binding. Right, so that is really, this is just part of the system, right? What platforms do anytime, right? They just compare these two strings and then they say, oh, that works, right? So that there's no performance degradation. There is a difference, however, if you compare to passwords and OTPs, where you just send a bearer token from the client to the server, as opposed to in the FIDO world, asking the server for a random challenge, do a computation on the client side, and then send it back, right? So there are some differences there, but overall, FIDO is a very fast authentication. And if you measure the authentication time that you get in practice, FIDO is much faster than existing authentication protocols today, like passwords or OTPs. And it's good statistics around that. Does that answer your question?
Yes, he agrees.
Great, thank you.
Okay. Any other question? No, thank you, Rolf. Thank you so much for connecting with us and making us aware about this FIDO authentication.
Great.
Thank you.
Thank you for the invitation.